everyone. My name is Maureen Cunningham. I'm one of the senior investigators at the Center for Global Health, and it's my pleasure to introduce the speaker today, Dr. Geoff Plumlee. He is he's Associate Director of Environmental Health with the United States Geological Service in Reston, Virginia. And prior to that, he spent 30 years as a research geochemist with the USGS here in Denver, Colorado. His research is focused on understanding links between geology, environment, disasters, and human health. So we look forward to hearing what he has to say. Thank you.
Great. So, do you know if he's filming? Oh, I think we're okay. Sorry, we tried to get in touch with you. But, well, I don't know if he's filming, but I guess so. Well, thanks everybody for coming. I really appreciate your time, and I appreciate the opportunity to talk. Just want to let you know that my wife took your global disasters and health classes last fall, and she really loved them. So it was a really good experience, and I actually was very happy to learn a lot from her when she came home and talked about all the great things she learned each day. So it was pretty intense, but it was a great course. So I probably made a mistake by putting compelling, because that always creates expectations. So I'll modify it by saying, at least for me, it's compelling. I've had a wonderful career with USGS, been able to work on a lot of really cool things, I think, and hopefully you'll think they're cool too once I get through. So I'm going to give you kind of a whirlwind tour through a lot of different aspects. I'm focusing mostly on the global part. There's a lot that we've done within the U.S. that I'll let you know. I can give you some links to if you're interested. This I'll talk about in a little while. This is an area in Zambia, a town called Kabwe, and these soils and dust that the lady is dusting have very high levels of very bioaccessible lead. So I'll talk a little bit about that later in the talk. And so if you want some more information and are interested in any of the things that I've talked about, this web link to my personal web page has a lot of the publications that will get you further information, or you can send me an email, gplumlee@usgs.gov. So, how many of you have heard about the USGS? Okay, good. Well, we're a little agency within the Department of Interior. We're a science agency. We're natural science. And this is from our webpage from 2 days ago. We provide science about the natural hazards that threaten lives and livelihoods, the water, energy, minerals, and other natural resources that we rely on, the health of our ecosystems and environment, the impacts of climate change and land use, and we develop new methods and tools to supply timely, relevant, and useful information about the Earth and its processes. And so that the mission area that I'm now in charge of deals with the health of our ecosystems and environment, but we're one of the unusual mission areas that our work touches every single other mission area in the USGS. So energy and mineral resource development, as you'll see in a little bit, plays a role in environmental health. Climate plays an obvious role in environmental health and things like that. So USGS, I think, is a pretty valuable source of information, and the website is www.usgs.gov. And hopefully you can find your way around in there. We're still trying to figure out how to communicate, I think, though, because it's not always very accessible. But and this is one of the highlight pages. This is an issue of environmental health. A whole series of papers just came out in Science of the Total Environment looking at mercury contamination across Western North America and how that contamination comes from many different anthropogenic sources and some geologic sources, and how it's being taken up by fish and birds and moving up the food chain and the potential exposures to humans. So if you're interested in mercury, this is a great issue, and you can get at it through the main part of the web page. So our folks here are familiar with One Health. I would presume you are. Basically, One Health is the recognition that there are direct relationships among the quality of the environment, the health of wildlife and other organisms, and human health. Now, I put in here a volcano erupting because I want to stress that the environment includes the physical environment as well. And as you'll see, the Earth actually produces a lot of contaminants that can produce a level of impacts on environmental health as well. And so here's the living environment and fish and wildlife and insects. And here's human health. Primary exposure pathway for kids is hand-to-mouth contact, and I'll be talking a lot about that in a little bit. The USGS Environmental Health Science, the mission area that I run, plus activities in all of our other mission areas, is what I would call transdisciplinary science. We're interdisciplinary within USGS, and we're transdisciplinary because we work a lot with health agencies. We help basically understand how the environment influences both toxicologic disease and infectious diseases in humans and other organisms. And a key part when we deal with human health, we have a few people with masters in public health degrees to help us communicate, but we largely work with the public health folks to provide them the science that they can then use and apply in their work. And we work back and forth, we collaborate a lot, and I'll talk a little bit about that too. So you can see Gulf oil spill, volcano erupting, water quality. We use remote sensing, specialized remote sensing. This is a wildfire burned area north of Los Angeles that we worked on, where we can map soil minerals that play a role in how fast the burned area recovers, how there might be ash and toxicants in that area, and pathogens. We do work on infectious and zoonotic and vector-borne diseases, like we have some peripheral work on Zika. And the Gold King mine spill that happened last year, we weren't working on that, but we provided in the past 20 years a lot of baseline science that should be used to help inform how they go about cleaning up abandoned mine lands. So I thought I would give you sort of a whirlwind tour, as I said, about a lot of stuff that I've dealt with in my career. And then the last one I'll talk a little bit about where in my new job, the mission area that I manage has a lot of activities related to vector-borne diseases, zoonotic diseases, the environment, and contaminants, and how contaminants might influence. So a lot of different health colleagues, both within and outside the USGS, and this is a partial list of all the health scientists we worked with: CDC, National Institute of Environmental Health Sciences, Harvard University, Boston Children's Hospital, National Jewish, Cecile Rose. Here, I've co-taught with Cecile Rose and Mike Van Dyke from the Colorado Department of Public Health and Environment. I forgot to put his name up here. For the last 9 years on a course on environmental exposures and health. And so we're actually teaching that this fall. And I'm still teaching it, even though I've transferred to Reston, because most of my lectures are now recorded and online. Many others, and then we have a bunch of other colleagues that I'll talk about in the Whirlwind Tour. So first one, I wanted to talk about mining in the environment. Mining is metal mining, lead for lead, copper, gold, things like that. It operates on a large scale. The nation and the globe need mineral resources like copper to keep our quality of life and grow and build cities and build cars and things like that. But unfortunately, mining also can have, particularly if it's not done properly, a certain level of environmental impacts. And we recognized that a long time ago here in the U.S., but overseas that there's still a lot of issues going on, and even in the developed world, I'll talk a little bit about, there can be things like mine tailing spills. And so what's in mining environment, what aspects of mining can produce things that affect the environment and human health. And this project we worked on starting in 2000 in the Philippines is a good example. And the USGS worked with Armed Forces Institute of Pathology, Uniformed Services University, University of Arizona, and several other folks, University of Diliman, Philippines, to do an independent assessment of mining-related environmental, engineering, and health issues. I'm going to focus on the environmental and health issues. So Marinduque is an island about 70 miles south of Manila, and it's a pretty small island. You can see the scale bar there, 5 kilometers, so it's probably maybe 30 to 40 kilometers wide and about as tall. And from 1975 to 1990, they mined I guess I can't use my pointer, I'll use this. They mined copper ore from a large-scale open-pit copper mine here called the Tapian Pit. The Philippine government gave them permit to pump their tailings from the mine after they extracted the copper minerals to a causeway here, or well, basically they just put a series of pipes on and just kept piping and pumping. And so essentially this whole bay filled in with tailings. There was such an opposition of the locals that you might understand why, that when they ran out of ore in this open pit and they opened a new open pit in 1990, they decided to not do near-shore marine tailings deposition. So they took the tailings and put it back in this pit. Now the problem was that they put a drainage at it at the bottom to keep the water level low. They plugged it, but in 1996 that plug failed and several million cubic meters of tailings came rushing down the Makalapnet into the Boak River and actually filled up the river channel all the way out to the ocean. And this is a view from the air where you can basically see 3 or 4 feet of tailings filled the whole river channel. And so we were asked to come in and also in 1993 there was a big debris flow with a lot of mine waste that came down and actually killed a couple of people during a monsoon from the northern part of the mine site. So we were asked to come in by the local congressman who found our website online to give an independent assessment of what are the real versus perceived impacts. And they were hoping to use that to establish a path forward for how they might fix it. So as of 1999, when we first visited, they'd done minimal amount of cleanup here, and so they were basically locked in arguments of how to dispose of cleanup. The mining company wanted to take all the tailings from the riverbed and just dump them out in the ocean, but the island was vehemently opposed to that because of the nearshore tailings deposition that they practiced for 15 years. So we went with Armed Forces Institute of Pathology. One of Jose Centeno's areas of expertise is arsenic poisoning, and they were convinced that there was arsenic poisoning, arsenicosis, keratosis of the skin. This is an Armed Forces Institute of Pathology publication, and basically these were some of the folks that they thought had been exposed to arsenic as a result of the mining. This is one of the local environmental activists. This is the congressman that got us involved. Very charismatic young fellow and Harvard educated, and very interesting person to get to know. His mother was the governor, and who was also very interesting. She was one of Imelda Marcos's Blue Ladies, advisory ladies. Ferdinand Marcos was the dictator that ruled the Philippines. So because of that connection, there was a lot of distrust with the family, but I genuinely felt that the congressman was actually trying to do the right thing. So here we're looking at signs of arsenic poisoning that were attributed to the mine. We also did sampling in 2000 and 2003. 2003 obviously was after 9/11, and we had I don't know if it was just a show of force, but we were accompanied where we did our field work by about 20 guys carrying assault rifles, but we never worried too much because we were always accompanied by probably 60 folks from the local area, and that was a really fun and good experience. So we did a lot more work there. They actually, the health folks did a lot more, basically things like this were also attributed to the mining activities as well. And there was also, the big issue was lead poisoning, that they found elevated blood leads in some kids living particularly in Kalankan Bay. So this is what we saw from 2000 to 2003. So basically they replugged the failed plug here, and the pit started developing water. We saw mine waste piles that were just melting away. Fortunately, they were, at least when we were there, held back by siltation dams, but one of the dams here was one that had failed to produce the 93 debris flow, and it was already filled, and the mine wastes are melting into it as well. But what we and this river, the Magpog, is actually a fairly small river basin where the mine site basically is the dominant source of metals and water. This is very acidic drainage that comes off these mine waste piles, acid mine drainage with high levels of sulfate, copper, iron, aluminum, manganese, things like that. And because it's such a small watershed, the impacts are felt all the way down to the ocean. In the Boac River, it's interestingly a different picture. There's still multiple acid rock drainage sources coming out of the mine site. And for now, the tailings are being caught, but basically all the tailings from the 93 spill in 2000, we could actually see them here, about a 3-foot high that the berm or a deposit that the river had cut through. But by the time we were back in 2003, there was so much erosion from deforested areas to the areas south of the mine that it actually had filled up and buried the tailings and was actually supporting some growth. So it was a very interesting situation, very dynamic environment. And again, the concern about arsenic poisoning and lead poisoning here was in the areas around the causeway that had been constructed, basically filled with tailings. So the distribution, here's the tailings causeway, but the tailings extend probably this far into the ocean around it, under water. So as I said, one of the key, we found large, significant environmental damages, mostly related, and from the ecosystem standpoint, copper was, and acid and iron and aluminum were the main issues, because all those things are very degrading to aquatic life. The Boac River system actually was working because it's being diluted by a big river coming in from the south. In this stretch was actually recovering, and we're starting to see return of the aquatic insects and fish and things as of 2003. But then another source of acid rock drainage started forming, and it basically sent another pulse of metals down. And so this river is trying to right itself naturally, but the humans aren't doing much. We're not doing much at the time. I still don't think they've done much. So, as I mentioned, lead poisoning was one of the biggest concerns. This is out on the causeway in 2003. And one of the things we did, we analyzed the tailings that were above ground, and we collected samples out in the bay of sediments and pore waters. And what we found was that the lead levels it's a copper mine, and it's in a geologic environment that is very low in lead. And what we found was at the max 15 parts per million lead. And that's actually lower than most rocks here in the U.S. The Pikes Peak batholith, the big pink rock that you see underlying most of Pikes Peak, has probably twice that level of lead. So what we did see, our medical folks did a fairly complete assessment, and they basically found that there were other things like leaded paint, and Philippines actually continued to use leaded gasoline up until the early 2000s or late 1990s. So our health folks said, well, you can clean up, you probably are going to have a tough time cleaning up the tailings in Kalankan Bay, but and you could clean them up. Even if you could clean them up, you would still not see a benefit from a lead standpoint, because that was not what was contributing to the lead, and basically said they needed to look for other sources. So we had to report out in 2005, and we went around, the congressman arranged a series of town hall meetings in all the different villages, and this is us, that's me, and this is CP David from the University of Philippines, Diliman. And this is one of the challenges, is risk communication, and we not only, this was somewhat of an educational issue as well, because most of the people in these villages do not have a high level of education, but then the main thing was that they spoke Tagalog, and a lot of them didn't actually speak English. And what we very quickly learned is that they were really upset that we didn't find the mine as the source of lead poisoning, even though we found a large amount of environmental problems that were very clearly linked to the mine and ongoing environmental problems. They basically were very upset, and this came out from one of the environmental activist groups and turned our study, which we were funded at about a $400,000 level by the Philippine government, but we actually provided probably 3 times that amount of value when all was said and done with in-kind stuff. But basically they said we were a costly exercise against environmental justice because we didn't confirm what they were expecting us to confirm, that the mining was the source of the lead poisoning and the arsenic poisoning. It's also the tailings were very low in arsenic. So we actually think what they were doing was they were measuring total arsenic in the urine and it was actually organic arsenic from consuming fish, and you can get very high arsenic levels, but it's organic and not as toxic. So we did report out to, this is the Secretary of the Department of Health of the Philippines, and they basically said, well, we were hoping to use this to go after the mining company, but you've basically shown us that we need to do some different planning. But unfortunately, as of 10 years later, we don't know that anything else has been done, because the Philippines is still it's not something where action gets taken. It's a country where action doesn't get taken very quickly without a lot of debate. And so unfortunately, the mine is still sitting there bleeding acid and metals into the environment. So it's all the people are wonderful people, and we really enjoyed it, but it was a very clear challenge for us to come in and try to communicate, and we understood why they were anxious to have the mine show as the source of every problem, but again, it was a big communications challenge. So a different, some of my things didn't show up. This is a different project we worked on. There should be a logo for CDC and Agency for ATSDR, Agency for Toxic Substances Disease Registry, and Doctors Without Borders. In 2010, Doctors Without Borders was doing routine medical surveillance in northern Nigeria, looking for malaria and meningitis. And they started in a number of northwest Nigerian villages. They started finding a number of villages where there were fresh graves of kids less than 5, and a lot of the kids that were alive, still a little bit older, were showing signs of convulsions and vomiting and blindness. And they were originally thinking it might have been malaria, but they fairly quickly saw that there was some mining activity going on, or artisanal mining, and they thought to look for lead, because those are also symptoms of extreme lead poisoning, and lo and behold, that's what the problem was. So basically in northern Nigeria, we think total of around 700 children have died as a result of the lead poisoning. They're all under 5. And there are several thousand others that have been left permanently disabled. And it's really, for this day and age, that's a really unheard of number of folks to be, a number of kids to die and be affected. So this is Zamfara State in northwestern Nigeria. And there are a few mines. These are the villages that were most heavily affected, Yargama and Doretta, but there were a number of other villages that were also doing this mining. So CDC got involved in May in response to of 2010 as a result of a request from the Nigerian government and U.S. State Department. They went and did with Doctors Without Borders and Terragraphics Environmental Engineering and the Nigerian government representatives. They did a really, really good field campaign where they actually did surveys looking, and they basically realized that these villages, they were doing processing of gold ores, and so they did a lot of epidemiology intelligence and health assessment studies. They collected blood lead samples, they did field lead analyses. A number of their field analyses pegged off and exceeded the upper detection limit of the process that they used. They did a lot of analyses of soils with this handheld X-ray fluorescence device that gives pretty good numbers for total lead, total metals. And they found analysis, and they sent a number of lab analyses, a number of samples back for lab. They found up to 400, actually that number has increased to 700 micrograms per deciliter, which is quite astonishingly high. And they also found blood manganese up to 41 micrograms per liter. And so they found extensive lead contamination. They asked, so basically this is what CDC, ATSDR, and Terragraphics found. They were doing artisanal mining from these different mine sites. They're climbing down on ropes, so this is truly 1800s scale or early 1800s scale processing or mining by hand. They would bring it up and they would transport it In 2010, somebody arranged a distribution network and tried to organize it. They would ship the gold ores to different villages, and families would buy a bag of the ore, and then they would set to work processing it. They would first crush it by hand, and I don't know if you can see all the dust, but there was a yellowish dust, and this guy is just coated with it. And then the same people that set up the distribution network also installed flour mills in a number of the villages. So then they would take this crushed rock and grind it, and they would move it through several times. You can see all the dust coming from that. Again, that was a fairly recent development. And this is another operation. This is the flour mill, and that's the ground ore. And in all the, we never went from the USGS, but we actually were getting ready to go, but then all the Boko Haram separatist activities started happening, and we were prevented from going. But in all the photographs that CDC took, they're always kids that were very close. If they were not observing, they were actually involved with the grinding and the processing. And basically, they stored the ore in between processing steps in repurposed flour bags from USAID. These are sort of a synthetic burlap. You can see the size for scale. And those are very leaky bags. So they would bring them into their compound. They would do a lot of the work in the compounds. And a lot of the processing, they didn't take pictures, but a lot of the processing was actually done by women in the compounds. In the Muslim culture, apparently they basically were restricted to living in the compound, so the ores would be brought in and the women would do a lot of the work. There were always kids around, and then they would literally bring the bags into their adobe huts at night to safeguard it, and was very leaky. The bags were very leaky. They would also wash it and sluice it. Sluicing tends to help them gravity concentrate the gold. But a lot of the sluicing would produce all this wet clay material, and they would actually sluice into some of the waterways as well. And you can also see there are a number of kids around in this step of the process. There's a little kid there. And then they would amalgamate with mercury. Amalgamation is the typical way they process gold ores in these artisanal mining camps around the world. It's the primary health concern in almost every other place except northern Nigeria. And it is going to be a concern in Nigeria, but the lead just happened to be the one that hit first. So here they're mixing the ore by hand with liquid mercury, and you can actually see a few little white specks of mercury globules. And this is the CDC took a mercury vapor detector that measured quite high levels. So after they mix it with the mercury, they then volatilize. They put it on a sheet of aluminum foil in the fire. The mercury basically soaks up the gold and forms an amalgam, just like the silver amalgam that was used for teeth fillings. But then they smelt it in open fires, and there's a little speck of gold that you can see there. That's what they get out of one big bag of the ore. But that's enough to make it economical for them, very economical compared to their subsistence agricultural living. So that's why it's so widespread. And they actually were measuring very high levels of mercury with the mercury volatilizer. So CDC asked us to get involved to help them understand the exposure pathways. And these gold ores that they're mining were quartz veins. Quartz is a crystalline silica, but it had not only gold in it, but it also had lead sulfide. Lead sulfide, there's been work done on that by EPA and some folks at various universities, John Drexler here at CU, to show that lead sulfide is it's minimally bioaccessible in the gastric fluids. So if there's hand-to-mouth contact of lead sulfide, there's very little dissolution and absorption of the lead. However, in the millennia before mining happened, natural weathering took a lot of that lead sulfide and put it into a more oxidized state of lead carbonate, lead sulfate, and lead phosphate. And this lead carbonate and also lead oxide are very bioaccessible in the gastric fluids. It basically, in an hour in the stomach, you can have up to 60 to 80% of it dissolved. and then some of it reprecipitates in the intestines, but it's still very highly bioaccessible and bioavailable. So basically, the geology was an underlying contributor to the crisis of the lead-rich, the nature of the lead ores. So the grinding, this is the ground ore from a flour mill. This is a backscatter electron scanning electron microscope image. The brighter the white, the higher the mean atomic weight. So lead shows up bright white, iron and some other things show up brighter or intermediate shades of gray. But I also put a lead map on top of this, so everything that's red is lead-rich. And what you can see, 250 microns, so all the ground ore, 250 microns is sort of the maximum size range for hand-to-mouth transmission. But you can see they collected sweep samples in the areas around, within the huts where there were dirt floors, and they collected sweep samples, and you can see all the lead in there. And this is a composite soil sample collected from around one of the whole villages. And basically the grinding took all this lead particles and put it into a size that's very easily hand-to-mouth, and in many cases would be inhalable as well. So that's the other exposure pathway. People inhale, and it gets trapped in the mucus, and by mucociliary reaction, they cough it up and then can swallow it. So that's also another way that it gets ingested. So that was a big exposure pathway, was hand-to-mouth transmission just from all the contamination. We basically found in some of the soil samples and eating area samples, we found up to 20% lead, and that was up to, and we also applied these physiologically based extraction tests using simulated gastric fluids to provide a good idea of how bioaccessible the lead is, and it was up to 50% bioaccessible. And so we could then translate that into uptake calculations, assuming clean to dirty conditions. And under clean conditions, basically 10 milligrams of dust today, and the clean is basically the environment we live in. Under very dusty conditions, which we think this was more like in Nigeria, it was up to 300 milligrams of dust consumed a day. And so when we do those calculations, we could basically say under the very dusty conditions, they were actually taking in and absorbing 10,000 micrograms of lead per day. And the FDA provisional total tolerable lead uptake level for a kid is less than 1, or no, it's 6, I think, 6 micrograms per day. So in this case, we're up to almost 1,000 times more above the uptake level. So incidental ingestion by hand-to-mouth contact is very clearly one of the dominant exposure pathways. We actually also looked at samples of grain that they had either ground with their flour mills. When they didn't grind the ore, they ground them with the flour mills. They ground their grains with the flour mills. And so we looked at various samples. This is from a ground foodstuff sample under the scanning electron microscope. And again, you can see these bright particles are the lead carbonates. And we can also see steel grinding chips in there as well. So these grains actually acted as fuzzballs and Swiffer fibers. And what we found there, that even if they were just consuming the grain also, the unground grain also had very high lead. It also had very high mercury. So basically, it wouldn't take much of the grain consumption to exceed the FDA PTTIL for lead.
Question.
Yeah.
Now, is that because they were reusing those bags to carry their grain as well? Or is that just from the proximity of the storage, like in their house?
Yeah, I don't know that they actually repurposed the bags to carry the grain. That's a good question. I never thought of that. We think it's actually mostly because of all the dust flying around. And so both the ground samples, they got dosed pretty heavily by contamination from the flour mill. Mm-hmm. And then the unground stuff we think was coming from airborne contamination. UNEP sent a team in to look at the groundwaters, and we think that the groundwaters, they found some high lead levels. We think it was all mostly particulate form, and it's again this very highly bioaccessible lead carbonate. So even if they drink the water, They're going to be getting bioaccessible lead in the particulate form. But we were based on the concentrations they measured, we were able to show that water uptake was subordinate to soil uptake. They also, I mentioned the sluicing, the clay material that makes perfect adobe bricks, but it also has very high lead levels, 8,000 parts per million. The EPA residential soil screening level for lead it is around 400 parts per million. So again, the houses are going to be a continual source. Anyone that was built with these is going to continue to abrade into the environment. So what were the issues? Basically, in addition to the severe lead exposures of bioaccessible lead, we think there's also a looming crisis for lead poisoning for pregnant women because the exposure levels that we calculated exceeded by far the PTTILs for pregnant women and for adults. There are probably going to be longer-term exposure issues for the workers. The whole issue of mercury exposures, which is the primary problem in artisanal mining around the world, has yet to be manifested, but we're pretty sure that's going to happen. Mercury contamination, because they would re-sluice and amalgamate and re-sluice and amalgamate, and so there was probably a lot of mercury being dumped into the streams. Manganese, arsenic, and antimony we also found were very high in the ores, and I noted that they found very high blood manganese. So one of the things that our health colleagues pointed out is manganese and lead co-exposures can enhance lead toxicity. And then when you see all these dusts, these were crystalline silica veins. So there's a lot of crystalline silica, and crystalline silica, freshly ground, is also a big problem from silicosis and silicotuberculosis and kidney disease and things like that. So what's happened? Well, the Nigerian government sort of banned, and then there was so much objection. The artisanal gold mining banned it, and then there was so much objection, they started it up again. And so Terragraphics in particular, working with Doctors Without Borders, Médecins Sans Frontières, they basically said you need to move the processing outside the villages, so that at least gets the contamination sources. And so then all the standard industrial hygiene things that they can do, like try to not get clothes dirty and bring them back into the family compounds. Don't bring the ore into the family compounds at night. And in these most heavily affected villages, Terragraphics did this very heroic effort to actually scoop up, using handheld XRF as their guide for lead content, scoop up the most contaminated soils and then replace them with 6 inches of uncontaminated soils. And then they were able to show that that substantially reduced the exposures, and then the kids that were there underwent lead chelation therapy. And again, we helped them develop these methods, knowing what they were how they were getting exposed for safe ore processing practices. So, how much time do these usually go?
We have a room until 1, and
okay.
Usually there's about 5 minutes of questions.
Okay. Well, I'll keep going for a little while longer then.
I have a question now, though.
Yeah.
I'm curious if there was a ban imposed and then the ban was lifted. Obviously, the communities had some awareness of what was going on.
Yep.
But I'm curious if you know more about how the risk was communicated, as in the case of the Philippines, and were they willing to basically, risk their health for this additional income?
Yeah, the last part was basically what happened was they explained the risks, and there was such an outcry because this is a lucrative way of getting income for them. So, and even once they knew it, they were, even though there are actually quotes in the newspapers about a guy saying, "Well, I'm sorry that this has affected my younger child, but this is the way I can have my older children afford a house. This is the way I can leave a better legacy for my older children." So it was just really sad stuff like that was driving this, and the Doctors Without Borders and Blacksmith, which is another environmental NGO, and Terragraphics did very good communication, worked through the emirates. Each of these villages has an emirate. As I said, it's a Muslim. It's in the Muslim part of the country to the north. So they've done a lot of education. So in those villages, this is actually a fairly recent news piece from 2014. It seems like they actually have helped the problem, but the message is either not getting out or it's being ignored elsewhere. This was in the state of Niger in Nigeria last year, where they found 28 kids that had died of lead poisoning from the same process. So again, there needs to be more regional communication. We've done work on another place with World Bank in Zambia. This is not a gold mine, but it's a lead zinc mining camp with 150,000 people living around it. And it's the same culprit, it's lead carbonate. Lead zinc ores, there's a lot of artisanal remining of them. And they actually take some of the mine waste. There's probably 50,000 people living on or adjacent to the tailings in the mine waste piles. And so they do artisanal reprocessing. This is the photo I showed you up front. This soil that was collected by Gary Krieger with Newfields had probably 10% lead. And so you see all the dust, and again, it's lead carbonate dust. And in this case, they've actually found 30,000 cases. And what's astonishing to me is that here in the West, we never hear about it. We've never heard about it. So that's astonishing. The other interesting thing is that they actually, this is in a part of Africa where they practice geophagia, purposeful consumption of soils for cultural purposes, and it's primarily pregnant women. And they actually, we analyzed some of these edible soils, and they had up to 10% to 20% lead, and again, it's largely bioaccessible. So we calculated that that pregnant women were probably getting up to 50 milligrams of lead per day. And again, the PTTIL for lead is for a pregnant woman is probably 50 micrograms. So this is 1,000 times the, so you wonder what's happening there. And this is so off radar, it's kind of scary.
I'm sorry, they eat the soil like on purpose?
Yes, it's a cultural practice where it goes back, and there are a lot of cultures around the world that do geophagia, and it's mostly pregnant women, but they feel like they have to eat, culturally they're eating earth to get nutrients from the earth, and that helps them as they are developing their infants in the womb. And so in this case, fortunately, not all the samples were, not all the edible soils were made out of those mine waste, but that was one of the things that was communicated back. Was that they needed to get those off the market. A couple of other quick, interesting cases here in the U.S., but they actually have links to overseas on a much smaller scale. We worked with CDC and Harvard University Medical School on lead poisoning from folk cosmetics and folk remedies. And this was a case where there was an infant living in Boston with Nigerian parents. That came in with around 10 micrograms per deciliter blood lead, which is considered elevated, 10 to 12. And so they did a complete survey, and there was no lead paint in the house, nothing, but then they realized that they were using, they purchased, that the grandparents had sent from Nigeria Tiro, which is an eye makeup that's made out of, guess what, lead sulfide. So fortunately, lead sulfide is not nearly as bioaccessible, so that's why the infant only had 10 to 12 micrograms per deciliter blood lead, but that was essentially pure lead sulfide that they're applying as an eyelid, as a cultural practice. So that turns out that there's actually a fairly extensive practice of immigrants bringing or having their families ship them things culturally from overseas to here in America, where it gives them a sense of continuity with home. Another case, we got a paper that's just now coming, will be coming out probably within the next couple of months in Environmental Geochemistry and Health. The same group found an infant girl with 20 micrograms per deciliter blood lead, and they did the same sort of assessment. And the one thing they found was that they were using diaper powder that the grandparents had sent from Malaysia. And as it turns out, in a lot of cultures, lead is viewed as a great treatment for dermatitis. And so they analyzed the lead, and they found 60% lead in this diaper powder. It was mixed of a lot of other stuff, so we analyzed it for them again.
and found that, again, because it's lead oxide, like lead carbonate, is very bioaccessible. We also did, my colleague Suzette Mormon, who does our bioaccessibility tests, also developed a urine test, because if they were putting in the diaper, then the theory was that it could dissolve in the urine, and the dermal absorption, dermal uptake. So although there is dermal uptake of things in infants in that area, what we saw was that the lead was only minimally bioaccessible in the urine. But it's, again, very high in bioaccessible lead. So again, we think the exposure pathway was hand-to-mouth contact and through dusts and maybe the infant touching the diaper or things like that. So they stopped, and the infant is now, and the blood lead levels are way down, so that's good. We also just worked with the group on a charm that they extracted from a kid with Indian parents, and the kid had very high blood lead, and the charm basically had probably 20% lead in it and was dissolving the stomach acid. So these are interesting exposure pathways. I think I'll skip this. Cecile Rose at National Jewish is leading this study on deployment-related respiratory disease. Maybe I'll skim right through it. Basically, troops are coming back from Iraq and Afghanistan with very high rates of respiratory disease, and they're concerned of how they're getting it. So they were thinking it might be burn pit exposures. I don't know if you've all heard about this. Everything in the forward operating bases gets burned, so computer equipment, car parts, tires, anything they don't need, old uniforms. Then there's also concern about just the urban particulate matter, diesel exhaust, because of all the diesel generators used in both Afghanistan and Iraq. There was a sulfur fire at a mine in 2003 during the initial invasion. The Iraqis set fire to the sulfur being mined there. So that generates sulfur dioxide, so there are concerns about the troops that have been exposed to that. Then there's also dusts from what we call geogenic sources. So the whole issue, and this is Hamoon wetlands in Iran, and basically you can see these dust plumes coming back around. And here's Kandahar. This is basically an image of troops during one of these dust storms, getting a lot of dust from these wetlands. These wetlands tend to accumulate things like arsenic and pesticides and all sorts of stuff. The arsenic is sometimes natural. The pesticides obviously are coming in from upstream. So they're doing this deployment-related respiratory disease project, and we're actually looking at slices of lung tissue, working with the pathologists. That's what they see in their H&E section. Here's a slice. This is, I think, the pulmonary, one of the arteries. This is getting into the alveolar spaces. You see this bright stuff. This is a scanning electron backscatter. So the brighter stuff is mineral matter. So we can actually analyze it, and we can do point counts, and we can tell how much is geologically sourced dust versus occupationally sourced dust. So we can actually tell, based on what's in their lungs, the occupations. We identified a couple of folks that were from grinding professions. We identified folks that were welders and getting welding uptake. And we're actually able to tell, work with the pathologist, this is a particle cluster, and he thinks that's from the alveolar macrophage, which are the cells that work in the lungs to try to surround foreign matter and take them through the lymph channel into the lymph nodes. But there's also all this organic matter around it. We think that's actually the alveolar macrophage trying to dissolve these particulates. These are crystalline silica and feldspars, which are aluminum silicates. We can actually see aluminum, silicon, and calcium, magnesium, and everything in this organic-y rich, lighter, intermediate gray that we think is actually the particles dissolving. So it's partly dissolving. We've done a bunch of different disasters and you can, if you want more information on those, what are the environmental and health implications from the World Trade Center all the way through the Gulf oil spill, Hurricane Sandy, World Trade Center dusts. I think I'll maybe, since I'm getting close, we did quite a bit of work on that. I sent a team on the first flight back from Denver at the request of EPA and the Public Health Service, what was in the dusts. And we found they were a very complex mix of everything that had been in the buildings, but we actually, because we were looking at it with our earth science techniques, we actually looked at stuff that weren't typically looked at by the emergency responders, like concrete. Pulverized concrete has a lot of calcium hydroxide, which is a caustic base. So you put a little bit of that in a lot of water and you end up with a pH of around 12.5. So a lot of the people that had upper respiratory tract and eye illness and gastroesophageal reflux disease, they now recognize that was because of the caustic material in the dust. We also found bioaccessible antimony in the dust from fire retardants, and lo and behold, they found, and also bioaccessible lead, and that was from the antimony was fire retardants, the lead was from paints, and that was what they found elevated in the blood and urine of the responders as well. We do vector-borne diseases. That's in my current job. I manage folks that do that. So you've seen Zika. Basically, Zika really exploded last year late. They could see it was migrating. It started out in the South Pacific, and then it went into Latin America and the Caribbean. And this is it's all transmitted by Aedes aegypti. This is the known range of Aedes aegypti in the tan. This is what it's expected to be in some number of years in the future with global warming. And so you can see substantially more populations might be at risk. These things, Aedes aegypti really exploits artificial water, like ponds and tires and things like that. So that, of course, has led to a big rush to use pesticides. So what are the implications of the pesticides? We look at that. And when I moved to Reston in May, or when I first started working in May in Reston, there was one of these signs that popped up in the median of the road, even though Reston is outside the current area, but they were capitalizing on the Zika fears. Mosquito control, protect against Zika virus. So it's like, okay, they're going to start spraying in big time. This is what they're doing in Miami now, and you can actually see this guy at least is very well, relatively well protected. Here's a guy watching him standing in the cloud with, and dermal exposure is one of the issues. So there is going to be exposure concerns, and this is primarily a chemical called naled. There are bats bats are a very effective mosquito control agent, but they're one of the species that's sort of under attack from a variety of illnesses like white nose syndrome. So USGS has done studies in the Everglades with Park Service, and they show this same chemical, naled, above a certain level, if it's applied, it will kill butterflies. And so that implies that it's then having an impact on the pollinators. Butterflies, bees, or pollinators. And then just literally 3 weeks ago, a month ago, 1 million honeybees were killed by excessive use of naled. So even though it's important to protect against the effects of Zika, we need to understand what the second and third order effects are and how you can make decisions about how that goes. So anyway, I was hoping to finish up a few minutes earlier in this, but basically transdisciplinary science, where the earth scientists and the biological scientists are working with health scientists, I think is really necessary and essential to help understand a lot of these really varied and complex issues at the intersection of environment and health. So if you have any questions, I'll be happy to answer them. Okay.
Thank you so much.
Yes. Well, thanks for your attention.
So, I'm sorry, where did you say you are now? Where?
I'm with the USGS still, but I'm in our Reston headquarters.
Oh, Reston?
Yes.
Where is that?
That's in Virginia, Northern Virginia. So I'm now managing science rather than being a research scientist.
Does that work better for you or not?
It's different.
Always trade-offs.
So basically, as a research scientist, I obviously am very passionate about the work we were doing. Felt like we were doing a lot of stuff that was important, but with funding levels the way they are, I was very frustrated with our inability to get funding. So I thought, well, maybe I need to put my money where my mouth is and go take a management position. So one of the key things about my job now is that I go and brief members of Congress I brief Office of Management and Budget and other agencies, and we're trying to highlight what good work the USGS does in environmental health science, and it's sort of stealth compared to our other work on earthquakes, and volcanoes, and water, and mapping, and things like that. So I figured I would take the final part of my career and see what I could do to help my colleagues coming up and back of me have similarly fun and productive careers. So.
I actually had a question about the first group that you told us about in the Philippines.
Mm-hmm.
So they seemed to be interested in arsenic and lead,
Mm-hmm.
but it seemed like there were an awful lot of other things that were problematic as well.
In the mining related?
Right.
Well, yeah, there's crystalline silica, and we actually made sure to point out all the other things, but they hadn't looked for health effects of those. They just focused. They were very clearly focused on lead and arsenic because those are the two most common ones. So one of the things the health people recommended was you need to do a lot more. I'm glad you asked this question because we did communicate that they may not be looking at the right things, and that there might be other things that would be adversely affecting health that they didn't know about because they weren't looking for them. So manganese was another one. Copper's not so bad, but in some levels they might be getting exposed, and it might be an issue. So, and then there's also the other issue too of general health status, that nutritional status that needed to be factored in as well.
Because all that dumping into the water, it seems to me like it must have been protest because it wasn't a great idea for the
Oh, yeah.
population.
Well, so
that didn't seem to be.
that was, and the environmental impacts of that, and the impacts on their subsistence fisheries, all that was a huge impact. And we basically said the mining is responsible for this. It's responsible for the debris flow that killed people during a typhoon. And our engineers, the mining engineers, basically said all these siltation structures, it's not a matter of if, but when they fail, and there will be more debris flows that will come down and fill the rivers yet again with mine wastes. And so it's, but again, it's sort of frustrating for us to see that nothing seems to have been done in the last 10 years. And I suspect it's because of political challenges. So. Yes.
Does USGS do any work on dust storms and health in the U.S.?
Yes. Well, yes and no. We have in the past, and we actually have a project right now that's at a low level. Before I took this job, I was kind of stealthing it under radar, where we're working with CDC on valley fever. Valley fever is a disease caused by inhalation of dust containing spores of the soil fungus Coccidioides. And it's in the desert southwest in the Great Valley of California, the Central Valley. And that's actually one, it likes hot, dry conditions, the soil fungus. And so when humans disturb it, or erosion or earthquakes set up dust clouds, that's when you see outbreaks, or during spring dust storms. And actually, the range is expanding into southeastern Washington, northern Nevada. So we're working with CDC to help them understand if soil chemistry might play a role in how viable these soils are. So we're working with them on that. So it's a dust source issue. We've looked at dusts in the past. We would love to be doing more work on that again. So that's one of the things I'm trying to figure out how we can get more funding for.
So I was curious about the role that USGS has in, I guess, vector-borne disease, or in particular Zika virus. So is it more, I guess, looking at like climate suitability for the particular vector or mosquito vector, or is it also just looking at also adverse effects of insecticide use or increase in insecticide use in those regions?
Well, most of our work has been done in the realm of wildlife disease, and so vector-borne, most of our vector-borne work initially got its start in wildlife diseases, and so mosquitoes landing on one kind of wildlife and transmitting it to humans or things like that. The group that I look at focuses on environmental contaminants. We're now expanding our work looking at how environmental contaminants influence resistance to how environmental contaminants might affect zoonotic diseases, susceptibility, things like that. And what are the contaminants that result as like Zika from mitigation? So we're working now to come out with a summary of all the different pesticides that are used for vector control for mosquitoes, ticks, things like that. And then what are the environmental characteristics of it and what's known about the impacts on things like pollinators. So that's the kind of work that. And we also develop analytical methods to measure low levels of these chemicals in the environment so we know what happens. And we do a lot of work also on zoonotic diseases as well. We've got a big group working on avian influenza, which is in birds, and it's coming. Their migratory birds come all the way from China and then through Alaska and then on down into the lower 48. And there's actually an outbreak of avian influenza going on now, where they're seeing some in the U.S. There was one last year and the year before. One the year before actually killed the wild birds land in areas, and it gets transmitted to poultry. So there, if you were seeing the news last summer, poultry farms they had to kill millions of birds because of exposure to avian influenza. So we work on that too, and we look at sources and how it's transmitted, and we do things like avian influenza if they're in ducks or geese. When they excrete the virus, and the virus gets down onto the bottom of lakes, and then it can be a source of exposure for other birds that are bottom feeders that dive down and scrape stuff off the bottom, or so there are a variety of ways that we look at things like that. And how do viruses and bacteria and soil fungi survive in the environment is another aspect that we look at. And are there roles of contaminants that either help or hurt the degradation of those survivability? Great. Well, thanks very much for taking a full hour out of your day. So hopefully you get a little bit of an idea of what the USGS can do. We're a little agency, but we do quite a bit. We're not regulatory, by the way. That's one of the things we value, is that we basically say what the science tells us, and that hopefully is used for helping protect, and the regulators can use our data to make better regulations, and everybody else can use it as well. Thanks.
Thank you.
Thank you.